Hey guys, happy Friday. Sorry this video is getting put up late. I'm not gonna lie, I've tried filming this a few times and then words that come in my mouth don't make sense, just like that whole phrase. So we're gonna try to go through this. I try to pre-set up some of this notes. This is just really a trig review before we get into our next unit. Thank goodness we're moving on, we're doing things. So we have to do a little trig. Please take notes on these. You guys won't have your packets until you get back to school, whenever that may be. So having all this handy is going to be very useful for this entire next unit. So we're going to go through things that are useful with trig. Most of you have seen all of this before. This is going to be as quick of a review as I can make it, but I just wanted to run through it for those of you that need it. So what we're going to start with first is our right triangle, and our right triangle is fun because it can do lots and lots of things. So the first thing is just to make sure you remember all triangles in every single triangle ever, all the angles add up, or I wrote it in like shorthand, but angles sum up to 180. So you can add all interior angles up and they're always going to equal 180 degrees. So we have our right angle, which is 90, and A and B are all going to be 80 degrees added together. Then the next thing with our right triangles is we have the Pythagorean theorem. Honestly, Pythagoras was a really funny guy, back in ancient Greek. So if you ever wanted to look him up, he was a prankster. He was a mathematician. He was a jolly good time. But the Pythagorean theorem when it comes to right triangles is just that our side A squared plus our side B squared is going to equal the length of side C squared. So that's how we can always find our sides. As long as we have two of the sides, we can find what the third one is supposed to be. The next thing, and yes, I'm trying to go through this really quickly, is just our SOHCAHTOA. There's a whole story about the Indian chief SOHCAHTOA, who was always right triangles, and it helps us to find either angles or other side lengths as we go through all of our triangles. So you have the SO is the sine of theta is our opposite over hypotenuse sides. And then the cosine is our adjacent side over our hypotenuse side, and the tangent is our opposite over our adjacent side. So I'm going to use this triangle I have written here, just give you an example of what each of those means in regards to what we have here. So we're actually going to turn this angle A into our theta, and it's all relative to wherever you're setting up the angle that you either know or need to know. So for here, the sine of theta is my opposite side, which is side B. Length divided by my hypotenuse, which is opposite of my 90-degree angle, so that's C. Cosine of theta would be my adjacent side. Oop, I meant to write the letter. Erase. Better. So it would be side A divided by my hypotenuse, which is side C. And then my tangent of my theta would be my opposite side divided by my adjacent side. So tangent of theta equals B divided by A. So as long as we know two pieces of any of these equations, we can solve for the third. It's pretty straightforward to get to what our sides are going to be. So if you had, let's do an example. We'll have this triangle here. No, we'll use that as another example. Hold on. We'll have this triangle here. I need that to be a number. Man, take 42, still not really working. So we'll say that this is 55 degrees. And I know that this side length is 7 centimeters, but I'm looking for that side length. So what I would do is figure out what sides these correspond to for my SOHCAHTOA compared to my angle. So I have an opposite side and the adjacent side. So I want to use the TOA part of SOHCAHTOA. So I would have the tangent of 55 degrees, because that's my theta, my angle measurement, equals x divided by 7. So I don't expect you to have memorized the tangent of 55, so you're going to use your calculator. And it comes to about 1.43 equals x divided by 7. And then I'm going to multiply my 7 to both sides. And that's going to tell me that my far side length is 9.997. I'm going to round it up to 10 centimeters because I've already rounded once. So it's going to work pretty well there. But what if we need to figure out what our theta is? So over on this triangle now, I have all of my sides labeled, but I need to figure out what the angle is going to be. I already know that I have my 90-degree angle in the corner, my little stair step. So I can use any of my 3 trig functions to figure this out because I have all 3 of my sides. So I'm just going to go ahead and do the sine of theta. So sine is my opposite over hypotenuse. You don't necessarily need to write that part of it down every time you work it, but I would like for you to write out the sides that you use so that I can follow along and make sure that we're getting the right information into our trig. That's going to help me give you as much partial credit as possible. So my sine of theta is going to be my opposite side, so 48, divided by the hypotenuse, which was 73. That's not the right number. It's 48 divided by 73. So my sine of theta equals 0.6575. I'm just going to leave that number in my calculator. The only way to solve for theta now is to use the inverse function. So on your calculator, it's going to be the sine with a little -1. And then you are going to put in the number that you had. So if you leave the leftovers in your calculator and you can just insert the answer, that's going to give you the most accurate result. So sine of my answer, kind of like window, like that. Then it's going to give you that theta equals 41.1 degrees. So we were able to solve for either a side length or an angle just using our trig functions. Now, what if we don't have a right triangle? We're going to use any of these 3 equations, which all together, these are the law of cosines. You don't really need to know where this comes from. You just need to be able to have it ready and know how to use it. And really, it doesn't matter which equation you use because it just depends on how you're labeling your triangle. So it's all going to come out the exact same as long as you are using it correctly. So whatever side you're solving for needs to correspond to the angle that you use here. So let me write in one as an example. So we have this side is 4 centimeters. This is 5 centimeters. And then I have my angle here of 60 degrees. So whatever angle I know, the opposite side is whatever I'm solving for. And I'm just going to pick my A up here. So this is technically, in my head, going to be side A, which means that this is angle A for my equation. And it doesn't matter what order you put B and C into because we have our math properties where the order doesn't matter. So side A squared equals 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of that 60 degrees because it's opposite of the side that I'm looking for. If I was given both of these angles, I don't know, let's say this is 15. If I was given both of those angles, you need to choose the one that is opposite of the side that you are looking for. So here I can go ahead and type that in my calculator. 16 plus 25 minus 40 times cosine of 60. And I'm going to get that a squared equals 21. Just like before, don't forget that the squared is there. So then we're going to take the square root of both sides. So the square root of 21 is going to tell me that that side length over there is 4.58 centimeters. So that is your law of cosines. Again, you can use any of those three versions as long as you're making sure that your angle that you're using is opposite of the side that you're looking for. Then next up is the law of sines. And this is the last one we're really going to cover. Yeah, I had to think about that one for a second. So what this is saying is that the sine of any angle divided by the side opposite of it is going to equal the sine of the next angle divided by the side opposite of it. So if this is side C, then this is angle C. And then so this, if this is going to be side A, then this is angle A. And if this is side B, then this is going to be angle B. So it's going to be opposite of whatever you're looking at. So this happens to be the triangle that we just solved. So this C is 4.58 centimeters because we just solved that triangle. There we go. Now I know both parts of my C, so I want to use that section. So sine of 60 degrees divided by 4.58. And let's say I want to solve for the angle for side A. So I have sine of A divided by my side length for A, which would be 4. So I just pulled two pieces of it together. Now what I can do is I can do the math on my C side. So sine of 60 divided by 4.58. I'm going to write it over here. The sine of A divided by 4 equals 0.189. Now, the longer you can hold these numbers in your calculator, the better off you are. So now what I'm going to do is I'm going to multiply both sides by 4. And the sine of angle A is 0.756. So now I need to do the inverse of that 0.756 to get what my angle degrees are. So my inverse sine of that answer, still holding it as long as I can in my calculator, is going to give me 49.14 degrees. So that is going to go all the way up here for that angle. And you could do that for angle B as well because we have enough information for it. So this is just a really super fast review. You guys will not have any review problems today for this. You'll actually do a review worksheet on Trig for your Monday assignment, and then we're going to jump into our next unit on Wednesday. So have a good weekend. Just take down these notes. No note check. You'll be all set. See you next week.